Hello everyone, welcome to this video. In this video, we'll be answering this question that how can we prove whether a subset of a given group is a subgroup or not. So in order to answer this question, we can list three possible ways by which we can guarantee that the given subset is not a subgroup, right? So the first way is that we may show that the identity that is not present in the group, right? It is not present in the given subset, so therefore it will not be the subgroup of the given group. The next thing that we can prove is if we are able to find and identify such an element such that whose inverse do not exist, or if it exists is not present in that set. If that is the case, then also the given subset is not a subgroup of the given group. And lastly, if we are able to identify two elements from the set such that when we multiply them, whose product, or we can say if we apply the group operation onto it, then the resultant that is not present in the set, right? So this is the third point. So in order to understand this, let's see several examples. Suppose we have this group G, which is the group of non-zero real numbers, so all the positive real numbers except 0. So under the group operation that is given here is multiplication, right? So we are now considering a subset of this, which is given by this H. Now it consists of all the elements x of G such that x is either equal to 1 or it is a irrational number, right? If that is the case, then this does not form a subgroup of G. Why this is so? Because if you take an element square root 2 from it, it is an irrational number, therefore it is present in the subset H. Then if you multiply the same number with the same number, so that means it is equal to 2, and you know in your set you either have 1 or you have irrational numbers with you, so therefore 2 is not a member of this subset here. If that is the case, that means we are taking two elements, whether they are same or different, from the subset and multiplying them together, because here the operation that is given to us is multiplication, and after multiplication the number that we are getting is not present in the subset H, right? So therefore this is not closed under the given operation, so therefore this does not form a subgroup of the group G. Next, let us see for the same group G of non-zero real numbers under multiplication, if we have another subset K which is defined by taking all the elements x of G such that x is greater than equal to 1, in that case we say K is not a subgroup of G. Why? Because if you take 2 from K, right, then can we find the we can clearly take 2 from K because it contains all the numbers starting from 1 which are greater than 1, right? So 2 is obviously there in K, but 2 inverse, which is 1 by 2, that is not present in K. So that means the inverse is not present here in this case. Hence, K is not a subgroup of the group G. So I hope you understood this property, that how we may prove that a subset is not a subgroup. Well, that is it for this video. Thank you for watching.